Hey everybody, been working with my ground rod and my house ground again. Just playing around with that potential, knowing that it's line noise, backfeeding, EMF, inductive load noise, reactive backfeeding, whatever. Run it through a 4-way full wave capacitor and right into a rectifier and going right into a capacitor here. Got a couple different things set up, so it's going to take a minute to show you. But I got the voltmeter off because it's slowly draining it. But let me show you what the voltmeter is reading right across the capacitor. The initial startup. Okay, so it's hovering around 1 to 1.5 volts. Had it up to 2 a little bit ago, but that's not the interesting part. In series here, I'll show you a schematic in a second, is the galvanometer, and we are discharging that through, well, we will be discharging that through a primary of this old radio, I think it's just a line filter transformer or something like an audio transformer. I'm using a signal generator to drive a 3055 to drive 3 volts or 4 volts into this relay, which you see is flashing here at approximately 1 hertz. What we're going to see is the capacitance, or the energy that's built up in this capacitance here, being discharged through the primary coil here, and actually see on the galvanometer the currents that are being flown through there, and how the voltage is affected. So the first thing I want to do is hook up the primary coil. So now we're discharging at the 1 hertz a second, and you see on the galvanometer. Now obviously the slower I take it, the little more it builds up. So more current can be discharged at a time. However, I'm going to turn the frequency up now, much higher, to I'm going to go all the way up to 1200. Right here. You can see that we are inducing energy into. Hold on one second. Alright, there we go. Frequency counter was killing the signal. I had to unhook it. But now you can see what's coming out of this, the secondary of this here transformer. We're discharging it currently at 1200 hertz. And the galvanometer is not much. You can't see the actual fluctuation, but it is dipping, as we can see it at lower frequencies. Relays appearing to be on solid. But by tuning the frequency now, we'll go back down to the 20 hertz, about 40 there. We can see the pulses that are coming through. Does appear to be dampened with an extra little, whatever that is, a ring there. We'll go up to voltage tends to, the remaining voltage on the capacitor seems to increase as we approach the resonant state with that transformer coil. Right there is about 1150 hertz. Very short duty cycle. Their voltage is about as high as it's going to be here. So Now, what to do with it? I tried running it through the multiplier, but didn't quite have enough amperage to pulse the coil. I'm going to change things around a little bit for that. Get that fluctuation going on. I don't know what that's from. It definitely doesn't seem to be being drawn from here, because I can crank my my output level all the way up. It doesn't affect it. The voltage on the power supply going up to 10 volts. That relay will take up to 32. I'm all the way up to 25 volts now, and it's not really having any direct effect on this wave. So I don't think these. I don't think the MOSFET in here is leaking, or this. Well, that wouldn't really affect anything but this. And so this can essentially be assumed to be isolated. But I think I hooked the galvanometer up backwards when I rearranged it. It's not dipping that way. Maybe 20, 30 microamps. Back to our 1200. You don't see hardly any movement at all on the galvanometer. That's coming out of the secondary. That's extremely low voltage. It's only a 0.01 scale. Weirdness.